So welcome again. My name is Sander Gerz. And people often ask me, when I meet new people, where do you work? As if that has something to do with how they relate to me. Because I work at these two companies, Solvec and the Meteo company, and nobody has ever heard of these two companies. So there's no really point in discussing where I work. It's more of an interest to people, I think, what I do. And in the daily life, I'm a web developer. I've been developing for the web for for 20 years now, working for different companies, but for the past 10 years, I've been working in small teams on different websites. One of those websites you probably heard of, Buienradar, is a well-known project I did. But I build websites, basically. You can follow me at the Twitter address that's up there. And I'm also a board member of the .NET user group that you probably or should have heard of by now. So why am I talking about blockchain? Not because I was someone who was into blockchain like 7 years ago. Bitcoin was not on my radar. Rain was on my radar because I was working there, but Bitcoin or the blockchain technology was not on my radar. It's only about 2 years ago that a friend of mine introduced me to the whole idea of the blockchain, especially Ethereum, and not because he had much technology interest, but because he was making money out of it, and he encouraged me to invest and make money. And so this is my rig that I still have, with 7 GPU cards mining Zcash at the time, because it's off now, it's offline. When I first got the electricity bill, this is maybe not a very good investment. Okay. But still, the technology still fascinated me at the time, and still does. And so I've been reading about blockchain, reading about all the various projects that were going on, and I was so fascinated by the idea that I think that blockchain is a technology that will change. Well, maybe it's a little bit. It's going to change technology, the things how we work with technology in the long run. And also because of this. Does anyone know what this is? Yeah, the hype cycle. This is the traditional hype cycle that Gartner uses, and maybe a question to the audience, where do you think we are in terms of blockchain technology in this hype cycle? Here? Here? The word slope. Yeah, so we've been through the trough of disillusionment. This is, you could say, this is 2017, end of 2017, perhaps, when Bitcoin was reaching about $20,000. Well, according to Gartner, we're not there yet. So, according to Gartner, we're still, it's not 2020 yet. We're still here. We're in the phase 2. We're in the phase of, finding solutions and doing proof of concepts. And so I think that's an important, phase that we're in right now. So be aware that if you're in this industry, or if you're working with blockchain technology at this moment, there is still, a point in time where you can be disillusioned by everything that you've been doing so far. But it doesn't mean that we have to stop and wait for that moment. We can do it right now and ask ourselves the question, what makes distributed ledger technology the solution to our problems? And you may have noticed that I've been mixing. I haven't mixed anything, actually. I've talked about blockchain. Now, why am I talking about distributed ledger technologies, and why is the distributed ledger technology the title of the session when I started talking about blockchain? And the reason is that blockchain is an implementation of a distributed ledger technology. And Bitcoin is the most obvious one, most known one, like Ethereum. But given the problems that those platforms had, other platforms have come up with different solutions to the same problem. Platforms like IOTA or Hashgraph. And these are, they implement the same concepts, but in a different way, making it more, performant. So, especially in the terms of speed, those platforms are better. But in all the next slides, I will, because distributed ledger technology is such a long word, I can shorten it to DLT, but then everybody would say, what was DLT again? I'll stick to the word blockchain. But if speed is of the essence, and the end of this talk, the only thing that is holding you back in trying to in figuring out a way to use blockchain technology, the only thing is speed, then look at the alternative implementations of distributed ledger technology, such as Hashgraph or IOTA. Okay.
Sorry, speed in what terms?
I'll come to that. Yeah. Okay. So before we start out in venturing, finding out a way to understand this or answer this big question, we have to understand the key elements of a blockchain. And those key elements are the fact that it's a shared ledger. Shared ledger meaning that it's running a database on different nodes, each node having a complete copy, where computation is also decentralized and a system in which, or being decentralized, meaning there's no single node that can affect the data, its availability, or the data itself. Another key element is the deterministic behavior, which is a result of the use of smart contracts, and especially when Ethereum came about. We got this capability of running code in a blockchain. And the fact that it was deterministic is very important. Deterministic means that the same input will always get the same output. And that also has there are some limitations, but for example, there are no floating point arithmetics available in a blockchain, because floating point calculations are not deterministic. Floating point calculations can depend on the version of the compiler that you're running, the CPU that you're running on, and so forth. So a smart contract doesn't have all that. Another key element is the fact that that a blockchain is transparent. So there's complete visibility. It's complete information visibility, and that means that transactions are open to public scrutiny, and that a level of public scrutiny can lead to new levels of accountability. That is a bit of a that can create a problem in terms of privacy, because you would say, well, how does privacy and transparency work together? Well, the blockchain usually works with, or they all work with, public addresses. Now, those addresses don't effectively show you the identity of the person or the party behind that public address. So they don't reveal the complete identity. So there is still privacy at some level. Now, I have to be fair, most of those blockchains work pseudonymously, meaning it's not completely private, not completely anonymous, yeah, that works. Those 4 elements of a blockchain all lead to trust, because that's the basic idea behind the blockchain. It's creating trust, especially trustlessness. Now, trustlessness was such a big word that I didn't wanted to write it down on this slide. But it's the fact that people or parties can interact with each other without explicit trust. That's the whole idea behind the blockchain. And for those elements to work, we need rules. You know, this is the business logic of a blockchain. We need rules. We need a consensus mechanism. All the nodes in a blockchain have to agree to the state of the ledger. We need data provenance. All the transactions have to be traceable to their origin. We have to have immutability, meaning that data cannot change. And this results into finality, and I'll explain what finality is later on. Now, the various consensus mechanisms, there are various consensus mechanisms around. Who can give me 2 consensus mechanisms? Proof of work and proof of stake. Okay, so those are the most obvious 2 consensus mechanisms. And the consensus mechanism provides, effectively, it's designed to provide a timestamp. It's a timestamp, it's a specific point in time where a new set of transactions are added to the blockchain. And all the other nodes can then verify and validate if that set of transactions is indeed valid. These two consensus mechanisms, consensus algorithms, they help you decide when a new batch of transactions are added, because you cannot do this in parallel. You can't have, adding transactions all the time simultaneously. That doesn't work. Now, why would a node do this work? Especially in a proof of work environment, why would you, do this? Or why would, in a proof of stake consensus mechanism, why would one node be interested in, collecting blocks and then, or collecting transactions and then adding them to the blockchain? For the proof of work mechanism, that's easy. It's an economic incentive. when a node in the blockchain can when they are able to add a block to the blockchain, they are rewarded. Especially, and everyone knows in Bitcoin, you get Bitcoins to be to the node that gets the block added to the blockchain. The mining in this, that's what they call it. They get a reward. For proof of stake, it's another consensus algorithm. For proof of stake, it's more of an integrity incentive. You know, the miner secures its stake, and they don't get. Well, they do get a small reward in terms of a transaction fee, but it's basically the incentive for the node to add blocks to the blockchain is because his or her, well, maybe usually his stake is important to him. And stake is in this sense, you know, the amount of wealth that is in that particular node. Okay, so in the interest of time, I'm going to skip a little bit ahead. Another rule was data provenance. And data provenance means that all transactions can be traced to the origin. This is done by hashes and digital signatures. Again, I'm going to really move forward quickly. Another rule was that data is immutable. Immutable meaning the data cannot change. This means this is done by the fact that, you know, each block has a reference to the previous block, and the previous block has a reference to the block before. This makes it virtually impossible to change blocks. Now, in theory, it's still possible to change a block, but you have to do all the work again to recalculate and add the nodes to a blockchain. Again, these rules lead to finality. And finality in a blockchain has two meanings. One of those is, one of the meanings of finality is the fact that the guarantee that things never change. And the other meaning of finality is that the state or of the asset or the state of the transaction can only be found in one place. Now, finality is not achieved immediately in a blockchain. Finality is achieved roughly after 60 minutes in a Bitcoin blockchain, after six minutes in an Ethereum blockchain, and 720 minutes in another blockchain technology is called Next, that uses another type of proof of stake algorithm. Delegated proof of stake, they call it. Okay, so we have these elements of the blockchain. We have the rules that apply to a blockchain, but there are also flaws. So in our idea or in our process of determining if a blockchain is a suitable solution to our problem, we have to look at these flaws. And one of the flaws is that it's expensive to, you know, start a blockchain in terms of infrastructure. And there are a number of technology companies who are making it very easy, making it a lot less expensive. You know, you can fire up a blockchain infrastructure in Azure in about an hour or less, run it for a few days, and it won't cost you the bank. It will be like, 50 euros or something like that, and you're done. But it still can be expensive in terms of development and development time. There was a report came out recently that said that blockchain engineers are making $150,000 to $175,000 a year. So that's expensive, and they're hard to find also. If you're a blockchain engineer or blockchain developer, then you're all set. Another problem or another flaw in the in a blockchain is that it's slow. We were talking about speed before, and the problem with blockchain is that it's, we looked at this. For a transaction to be complete, to be final, it can take up to a couple of hours even before it's done, before it's final, that it cannot be changed. Now that's really slow. If you look at the number of transactions that are going on in regular blockchains, it's, if I'm not mistaken, it's about 15 transactions per second on Ethereum. That's not a lot. 15 transactions per second, whereas credit card companies, they run thousands of transactions per second. So it's relatively slow. There's also no way in a blockchain to connect to peripherals. Well, that's not entirely true. There are ways that you can connect to peripherals. You can connect to real-world entities by means of oracles, but it's difficult. It's complicated to do this. As I alluded before, a blockchain is not really private. Unless you're talking about blockchains that are specifically designed to do private anonymous transactions like Zcash or Monero, a transaction is not completely private. For general purpose blockchains like Ethereum, it's simply not possible. Another issue with blockchain development especially is it's very easy to make a mistake. If you're building smart contracts, it's not easy to do. You have to have a lot of tools. It's cumbersome. There are development kits making it more and more easy. But it's still difficult. It's not easy to debug your code in a smart contract, and it's very easy to get yourself into trouble. That for if you're just doing tests, it's fine. But if you're deploying and running smart contracts and there's actually money involved, this is going to be a very serious problem. Maybe you've heard of the decentralized autonomous organization, the DAO attack a couple of years ago. They lost $70 million in that hack. There was a parity bug that was last year or the year before. Parity bug. Parity was a wallet system that allowed for multiple parties to sign a transaction, and they had a bug in one of their smart contracts, making it possible to effectively remove bits of that smart contract. And in the end result was that they froze over $280 million worth of Ether at the time. So that's a big problem, of course. So we have these elements, we have these rules, we have these flaws. This is a way to figure out, the pros, whether the pros outweigh the cons, and this is a table. This is well, you can obviously see this is a table. This is a way of finding out if your problem matches or can be solved with a blockchain. But it's not a yes or no. It's not a true or false. It's a level. We cannot simply say that if decentralization matters, we can use a blockchain. Likewise, we cannot also say that if latency is important, we cannot use a blockchain. For each aspect, we need to determine what the level is of importance. And to do this, we're going to take a look at insurance claims. And insurance claims is a very typical example of using a blockchain. And especially big companies like IBM, Microsoft, consultancy firms like Ernst & Young and PwC, they all consider insurance claims as a typical example of where we can use blockchain, and they predict that blockchain in this industry, in the insurance industry, will be as common as SQL is right now. Because insurance has a number of problems. Insurance has a problem of fraud. They have complex contracts. There are human errors. There's difficult or complicated information flows, and there's time to process. And usually insurance claims are like this. There's a claim request, a review, analyze, settle, and close. That's pretty straightforward, pretty simple. But in reality, it usually looks something like this. A claim goes through the various stages. There are various third parties involved, like the assessor, sometimes the police, obviously the insurance company, the customer or the client making the claim, and if there's damage repairs, the shops that are doing the repairs. So it's a lot of involved parties, and not to forget, regulators are also involved because they need to inspect the whole process in terms of compliance, risk management, fraud, market conduct, and all that sort of things. So we can go through the various aspects of the blockchain and determine whether it's good to have it to be decentralized, deterministic, accountable, trustless, and we can go through each of these steps. Now, when I write these, I did this by myself. I decided that having a decentralized environment it's not bad, it's not particularly good, it's okay. Obviously, this is something I did by myself, but if you are in the process of determining whether blockchain can solve your problem, you shouldn't be doing this by yourself alone. You should be talking with all the relevant parties involved and determine whether this aspect is important or not. Actually, not important or not, or how important is it? So we can, but we don't have the time. But we could go through this table and discuss every element, but we're not doing that. Decentralized in the sense of this particular example means that there's no downtime. That's a good thing to have. There's no downtime because the blockchain is never down. You know, there's plenty of nodes always available, and because of its decentralized nature, it's also virtually, I'll not say completely, but it's virtually impossible to attack or to compromise it. So that's a good thing. But you could argue that if you have enough firewalls and security measures, you have failover capabilities, you could probably get something similar to the uptime of a decentralized environment. Decentralized also means that there is no single party of trust, so that's a good thing as well. The deterministic behavior of the blockchain in terms of smart contracts running for you, executing code and doing that automatically, that's also a good thing. The fact that it's accountable and that all transactions can be traced and the ledger provides a complete historical record is also a good thing to have, especially when you're talking to regulators. Privacy is a bit of a difficult issue because, as we know, it's not completely private, and for most insurers and all relevant parties, it's nice to know who you're talking to. So it's not that it's a bad thing, but it's also not particularly the best thing. And the fact that it all results to a trustless environment, well, when you don't have to rely on one single party, is also a good thing. How about the flaws of the blockchain? Well, it is expensive, but if you compare the expense that you have to make and related to the fraud that is going on, and that's quite a lot of money, you can say that it's not really that expensive. There is one problem, obviously, when you're talking about the expense, is that if they really, because then there's one party effectively running the show. So that can compromise your level of trust. The fact that it's slow, is that really a problem in insurance? Well, I mean, having had a case where I had to deal with the insurance because my motorbike was stolen, this took about 30 to 40 days to process. So having millisecond transactions is not a big deal. Having the whole transaction cut down to a couple of days would have been an improvement. The fact that there is no external data possible, you still have to verify the fact that your police report is valid. You have to verify that that the photos you took are indeed valid. There is some problem with the fact that it's difficult to do this external data input. As I said, you can use technical solutions to solve this, oracles they call them, and they can help. The fact that it's transparent is a good thing because it can help against fraud. And the fact that that there's room for error, well, you would hardly say that it's a good thing that there's a room for error, but it's neutral, or it doesn't have much impact, because if you're running your claims process in a smart contract or in a set of smart contracts, that claims process is usually one single smart contract running at the time, meaning that if there's a flaw in that smart contract, you're only affecting that single claims process. You're not affecting all the instances of the claims being processed at that time or afterwards. So yes, it's a problem that obviously bugs are a problem, but the scope of the problem is limited to a single claim usually. So it's not a big deal. Before we decide, okay, so this is good, we can use our blockchain solution, you have to consider alternatives as well. And for decentralized, you have a thing called peer-to-peer protocols. Now, people may remember Napster. Yeah. So this was one of the first peer-to-peer protocols around. But peer-to-peer protocols usually deal with decentralized storage and not decentralized computing. And decentralized computing also doesn't, you shouldn't confuse decentralized computing with distributed computing, because in distributed computing, you still have the decision making, the final decision making is centralized. And in decentralized computing, the decision making is decentral. All the code in a smart contract is run on all the nodes. Now that's not very efficient, but it's true. For deterministic behavior, how would you get deterministic behavior if you're not running in a blockchain? Well, you could run the code locally on your computer. First, you'd have to get the source code. Then you would have to compile the source code, and you have to trust. That's also a problem. You have to trust the compiler. But then you can be absolutely certain that if you input the same values in the method, you would get the same result every time and again. But as soon as you're doing remote execution, you can't be sure. You can't be sure about the deterministic behavior of that code. For accountability, now I've looked around a lot. Maybe you know of better ways, but the only pattern that I've seen that does give you a good alternative to the level of accountability that a blockchain offers is secure logging. And it's a pattern. It's I looked very hard, and it's just a pattern, and there are some implementations, but it's very difficult to find. In terms of privacy, you can go to Tor or VPNs. VPNs offer a limited set of a limited level of privacy because you have to trust the VPN provider, of course. So for the whole idea of, how does blockchain offer a solution to my problem? These are the steps you have to take. You go to the various features of blockchain. You check out the pros and cons and whether or not they help or hinder the development. You check out the features and see if if they're relevant to the problem, and you check out the alternatives. And you have to note that blockchain is not a feature, right? It's not a feature of your project. It's same way you don't advertise that your solution uses blockchain the same way as you don't usually advertise, perhaps to nerds or something, that your solution is built in Python or C# or Go or any other language. You don't advertise that as such. So there are lots of platform options. I'm just listing a few of them. Most of you know about Ethereum, you know Bitcoin probably, but there are so many other options, many more. There's obviously the website coinmarketcap.com. Anybody heard of coinmarketcap.com? Only a few, wow. If you go to that website, there are hundreds. I haven't counted lately, but when I checked last time, there were over 2,000 projects doing something with blockchain. Most of them are in the payment space, but there's many other options as well. Okay, so if you're interested in keeping up with all the trends and developments in the blockchain space, I've set up a Twitter account, bcradar.com. Oh, no, not .com. bcradar, it's just a Twitter account. You can email me at this address, and you can check out my blog at this website. And also, by now, an article is posted on this website. I scheduled it to be published at 4:30, so it should be up now. It's there, okay. And discusses this talk as well. Now we have 2 minutes for questions. Any questions? Yes.
Do you have some examples of projects that are now actually being used in practice of blockchains?
You know, real life examples of, yeah, well, one that comes to mind is, have you heard of Guts? Guts. Guts is an event ticketing system, and it's a Dutch initiative. They use the blockchain to sell or resell event tickets. You know, there's a big problem if you're trying to get a ticket for an event, especially concerts or things like that, where there's a couple of parties who just buy the tickets rapidly and then try to resell them at a much higher price, and the artists usually don't get any revenue from that, from the reselling of the ticket, and so artists are currently involved in this project, and they offer their tickets only on that system, making sure that you have a valid ticket, and the price is only limited to the price that the artist wants people to spend for the event that they're hosting. Guts, yeah. Any other questions? Okay, I think we're just about in time. Thank you for having me up here, and hope you enjoyed it. Oh, and if you're interested, I had a number of slides just in case we had more time. Next week there's a Ignite conference, and I'll be talking about using Azure in a blockchain environment. So if you're interested, check out next week's event at the Ignite in Amsterdam. Okay, thank you.